The second family of NoSQL databases are column-oriented stores. This type of databases are different from DBMSs, just because in traditional databases, tuples, let's call lines or rows, are stored in a wall. They are not separated from each other. In column-oriented stores, attributes can be separated. They are separated in column families and stored independently. And then the main point, just to know that every attributes are stored independently inside the distributed cluster. So the main issue is to deal with aggregate queries, just because now you have queries on specific columns and you can make aggregation on this column. Other ones are not necessary, so you earn some place, some time just by focusing on a specific column. That's the main point. Another interesting thing is that this feature makes more easy to insert new columns. And you have dynamic schema just by adding new columns, so they can be stored in different ways. Let's have a look on how the different column-oriented stores are built. So for every attribute, you can have a corresponding column inside the database. So here you have the employer, the specificities, and hobbies that you can have inside the database. So you have different column families, and with, of course, the identifiers that are repeated for every column in order to recompute the information and to make correlations. In order to make queries over column-oriented databases, you can have this type of query. For instance, how many professors there are at SILF. So you focus on the status and the employer. So you remove unnecessary attributes. So you only focus on status and employer, and then you filter out the information that are not required. And over these different columns, you make the intersection between them and you have your answer. The main issue here is to compute very complicated aggregations and very computational. Since you focus only on very simple columns, you are more efficient. Just you only need less memory in order to compute this information, and you can distribute more easily the operations all over the network. For these solutions, you can find, of course, the first one, which was called Bigtable from Google. And your other things like HBase, Elasticsearch, or Spark SQL, and other types of NoSQL databases that are column-oriented. So the main issue is to deal with aggregation and for correlations between different information separated in different columns. Of course, you can ask about Elasticsearch just because many people are interested in Elasticsearch like document management, but it's both column-oriented and document-oriented. But the way that it stores information inside is more column-oriented way. So it can be discussed about this.